Moving on to the next question. A convex lens is dipped in a liquid whose refractive index is equal to the refractive index of the lens. Then its focal length will be. The options are option A becomes 0, option B becomes infinity, option C becomes small but non-zero, and option D remains unchanged. Students, we can see that they have given a convex lens which is dipped in a liquid, and they have given the refractive index which is equal to the refractive index of the lens. So, straightforward we can use the lens maker's formula, which is given as 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. Since in this question they have given n2 is equal to n1, we get it as 1 by f is equal to 1 minus 1 into 1 by r1 minus 1 by r2. Therefore, f is equal to infinity, since 1 by f is equal to 0. So, the correct answer for this question will be option B, that is, it becomes infinity. ವಿದ್ಯಾರ್ಥಿಗಳೇ, ಮುಂದಿನ ಪ್ರಶ್ನೆಗೆ ಹೋಗೋಣ. A glass prism of refractive index 1.5 is immersed in water of refractive index 4 by 3. Refer the figure. A light beam incident normally on the face AB is totally reflected to reach the face BC if. The options are option A 2 by 3 less than sin theta less than 8 by 9. Option B sin theta less than or equal to 2 by 3. Option C cos theta greater than or equal to 8 by 9. And option D sin theta greater than 8 by 9. So students, let us look into the diagram first, where a glass prism is immersed in water. So now the ray of light is normally incident on the face AB such that it reaches the surface AC. On the surface, let us drop a normal such that the ray will undergo total internal reflection here. So if I choose this angle as I and I choose the other angle to be X, please look into the diagram very carefully. From the diagram, we can write the value of X as 90 minus I, since this angle can be taken as 90, and from the triangle, we can also write X is equal to, X is equal to 90 minus theta. Therefore, from these two equations, we can write theta is equal to I. For TIR to take place, the angle of incidence should be greater than the critical angle. Therefore, which is given by IC is equal to sine inverse of N2 by N1, where N2 will be the refractive index of the surrounding medium, which is 4 by 3, and N1 will be the refractive index of the glass prism, which is 3 by 2. Therefore, we can write it as sine inverse of 4 by 3 divided by 3 by 2. That is, IC is equal to sine inverse of 8 by 9, which concludes that sine theta is greater than 8 by 9. So therefore, if it has to be totally reflected to reach the face BC, the correct option for this question will be option D, that is sin theta is greater than 8/9. Let's move on to the next question. A container is filled with water of refractive index 1.33 up to a height of 33.2 centimeters. A concave mirror is placed 15 centimeters above the water level. Image of an object placed at bottom is formed 25 centimeters below the water level. The focal length of the mirror is, the options are option A minus 10 centimeters, option B 15 centimeters, option C minus 20 centimeters and option D 2 centimeters. Students, please understand and follow the steps very clearly. We have a beaker which is filled with water at a depth of 33.2 centimeters, and we have a concave mirror which is placed 15 centimeters above the surface of water. Now, the image is formed below at a depth of 25 centimeters. Let O be the object which is placed at the bottom of the surface. Students, clearly understand that this object will not be the object for the concave mirror. So, when viewed from the plane surface, the object appears to be raised. So, let us find out that particular distance where it has been raised using the formula n is equal to real depth by apparent depth. That is, apparent depth is equal to real depth by n, which is equal to 33.2 divided by 1.33. This can be simplified further, where 33.2 can be approximately written as 100 by 3 and 1.33 can be written as 4 by 3. So, we get the apparent depth as 25 centimeters. So, the total distance of the object will be 15 plus 25, which is equal to 40 centimeters with a negative sign according to the sign convention. So, here in this question they have asked us to find out the focal length of the mirror, which can be calculated using the formula 1 by f is equal to 1 by u plus 1 by v. Students, please clearly remember that the image distance will also be equal to 40 centimeters, that is 25 plus 15. Therefore, after substitution we can write it as 1 by f is equal to 1 by minus 40 plus 1 by minus 40, that is f is equal to minus 20 centimeters. Therefore, the option which is correct for this question is option C. That is, the focal length of the mirror is minus 20 centimeters. This sum can also be solved in a different manner. Since the object distance and the image distance are the same, to find out the focal length, the object should be kept at 2f. Since the object distance is 40, so we can write f is equal to 20 centimeters. With this, we come to an end of this session. Students, I hope all of you have understood what we have learned, and I have the belief that you will utilize all these steps. I wish you all the very best for your CET and other upcoming exams. This is Rajni signing off.